Welcome to This Explainer. Have you ever stopped to wonder how you can down a massive, spicy meal and your stomach just handles it without digesting itself in the process? It's pretty wild when you think about it. Well, you're in the right place, because today we're going to map out the incredible, highly orchestrated chemical factory operating right now in your gut. Now, looking at the actual physiological literature on this, it can feel, well, a bit like reading a foreign language. It's totally packed with dense chemical pathways and cellular acronyms. But hey, don't sweat it. We're going to take this giant wall of text and turn it into a super clear visual blueprint so you can see exactly how the machinery works. Because the big question we really want to answer today is this: how on earth does your stomach know exactly when to unleash the acid? I mean, we're talking about a highly corrosive environment in there. Producing acid at the wrong time or in the wrong amounts can lead to some serious issues. Let's find out how the body orchestrates this delicate balance so perfectly. Here is our roadmap for today. We'll look at the acid factory main engine, the 3 chemical managers, the intracellular signaling pathways, why histamine is the ultimate boss, and finally, where these signals actually originate. All right, let's jump right into part 1. The acid factory main engine. So, let's start right down on the factory floor with the actual physical machine pumping out the acid. Our source identifies the terminal enzyme in this whole process as the H plus K plus ATPase, which is way more commonly known as the proton pump. These guys hang out in the apical canalicula, which you can just think of as microscopic exhaust pipes. Basically, this pump physically shoves the H plus ions, literally the acid itself, straight into your stomach. Now, where exactly do these proton pumps live? They're packed inside what we call parietal cells. If you think of the parietal cell as the factory building itself, then the outside of these cells, specifically their basolateral membranes, kind of like the outer loading docks, are lined with receptors. These receptors are essentially communication terminals, just sitting there waiting for orders to turn those acid pumps on. Which brings us to part 2, the 3 chemical managers. So, if the parietal cell is our factory, who exactly is barking the orders to start production? Well, in this microscopic factory, the managers are chemical messengers known as secretagogues. As the text lays out, a secretagogue is really just a physiological substance that causes another substance to be secreted. Basically, they're the chemical bosses holding the megaphones yelling, "Hey, release the acid!" And we actually have 3 main physiological secretagogues, acting as our management team here: histamine, acetylcholine, or ACH for short, and gastrin. Now, each of these managers has a very specific receptor. Think of it like a unique lock that they use to get their signals into the parietal cell. Histamine uses the H2 receptor lock. Acetylcholine uses the muscarinic receptor lock. And gastrin, it uses the gastrin or CCK2 receptor lock. Moving on to part 3, intracellular signaling pathways. Okay, so once these managers bind to their specific receptors on the outside of the cell, what actually happens inside? They don't just, flip a simple on-off switch. They trigger these incredibly complex molecular pathways. Notice how the managers divide up their communication strategies here. Histamine binds to its H2 receptor and generates an internal messenger called CAMP. Meanwhile, acetylcholine and gastrin take a totally different route. They work through a pathway involving phospholipase C and IP3 DAG, which ultimately mobilizes intracellular calcium. So we're dealing with 2 distinct internal signals here, CAMP and calcium. Now, the absolutely crucial thing to grasp here is synergy. Firing up the proton pump isn't just an either-or situation. The text specifically points out that proton pump activation involves both calcium and CAMP working together. In fact, the whole secretory response to managers like gastrin and acetylcholine can only be expressed fully when CAMP is in the mix. This sets us up perfectly for part 4, why histamine is boss. So we've got our 3 managers, right? But here is the major twist in the chain of command. Histamine is actually the dominant player. But why? Well, you have to look at their direct versus indirect action. While gastrin and acetylcholine can act directly on the parietal cell's receptors, the text states they act to a much greater extent indirectly. Believe it or not, their main move is actually to order a completely different type of cell to release histamine. These other cells are called enterochromaffin-like cells, or ECL cells for short, and they hang out right there in the oxyntic glands. I love the nickname the text gives them, histaminocytes. Think of these ECL cells as the ultimate middle managers.
Gastrin and acetylcholine rely heavily on them to release the histamine needed to really get the acid flowing.
To quote our source directly on this, as such, histamine participates in the acid response to gastrin and ACH at more than one levels. Simply put, because histamine is the absolute sole provider of that crucial CMP signal we talked about, gastrin and acetylcholine physically cannot fully activate those acid pumps without histamine doing its job first. Histamine is literally the gatekeeper for the whole operation. So, why should you care? Well, understanding this specific bottleneck absolutely revolutionized modern medicine. This is exactly why anti-secretory drugs, specifically H2 antagonists, are so incredibly effective at treating things like heartburn and ulcers. Because histamine is the boss of the CMP pathway, blocking just the H2 receptor doesn't merely stop histamine. It actively suppresses the acid response to acetylcholine, pentagastrin, and practically any gastric acid secretory stimulus. You cut off the boss, and the whole factory essentially shuts down. All right, finally, let's look at part 5, where signals originate. Let's zoom all the way out for a second. What actually kickstarts this entire microscopic cascade the moment you sit down to eat a meal? Well, it all begins in the stomach's lower section, known as the antrum. When food enters, two things instantly happen. The pH rises, and the actual constituents of the food are detected. This triggers vaguely mediated reflexes in the enteric nervous system, or the ENS. Those neurons then fire signals straight to the G cells, prompting them to secrete our very first manager, gastrin, which kicks the whole factory into gear. And your nervous system is ridiculously specific about how it does this. The postganglionic neurons of the ENS elaborate acetylcholine, along with a specific messenger called gastrin-releasing peptide, or GRP. Furthermore, our text points out that when mediating these vagal responses, the dominant lock it uses is the M1 subtype of the muscarinic receptor. It is just a beautifully automated, perfectly timed chemical cascade. Your nervous system acts as the CEO, sending out highly targeted memos to get the factory floor moving. Understanding this exact chain of command, how food triggers nerves, which trigger managers, which ultimately rely on the big boss, histamine, to turn on the proton pumps, completely changed how we treat gastric disease. And honestly, it leaves us with a pretty fascinating thought. If blocking just a single receptor, that H2 receptor, can successfully suppress an entire complex network of physiological signals, what other incredible microscopic domino effects are currently hiding in our bodies right now, just waiting to be mapped out? Thanks for joining me on this explainer, and keep questioning how your world works right down to the cellular level.